the technical issues. I think I finally have the audio set up now. So I think I should be streaming, and you should be seeing my screen. Welcome to the weekly edition of the Hummingbot Live, our YouTube live stream where we go over the latest stuff we created in Hummingbot. So let me just check the video. Let's see here in YouTube. Make sure this is actually recording and sending some stuff. Okay, I think it is. Oops. Okay, let me pull this over here. Okay. All right. I think it's working. I believe. Well, yeah. So okay, great. So all right. So today we're gonna really kick off. We have more of what I think the past few weeks, Fede has covered a lot of how to do like a DEX screeder now on using Hummingbot. So I think if you watch the following live stream in the past, you probably have a good understanding of how to kind of like use Hummingbot and how to kind of set up a data collection pipeline that helps you find features and like filtering pools and those kind of things. And you can also set up Hummingbot to collect data. So today we're gonna kind of dive more into the DEX part of Hummingbot. Specifically this one repo called Gateway, which is a middleware that helps you standardize DEX API endpoints so you can call them programmatically and you're basically using a bot. So so let me just pull up the recount here. Okay, great. So you can ask questions if you want in either Discord in this live stream Quantslab section or in YouTube. I think I can pull up the chat right here somehow. 1 second. The chat. So getting organized here. It's like 8 o'clock in the morning on Friday, so I may need to actually drop off to get a bit of coffee and get a refill before we actually fully get started. Okay, great. I see the chat window here, so I can see what people are saying on YouTube as well as Discord. So I'm gonna pull this off to the side here a little bit, so I can. Damn it, lost the chat window. Oh, here, great. Here's the chat window again. Okay, right. So now I'm a little bit more organized in terms of the seeing what people are saying. So I will be able to, yes. Okay, great. So I should be able to answer questions now. All right. So so the first thing I want to do is kind of explain what Gateway is, the role it plays in Hummingbot, and then we'll kind of go into seeing the demo of it in action. Okay, so basically, in Hummingbot, it's an open source framework that helps you run a bot. And so, very simply, if I kind of just start Hummingbot like this, I have a CLI like this, and we can use it to run strategies. So, if you notice, there's something over here that says Gateway Offline. So, what that means is now you're just using Hummingbot in standalone mode. And so when you say connect, so that's a emoji. And so these are all the exchange connectors. So you notice these are all there are some sexes like Binance. There are some dexes, I guess, like Hyperliquid and Injective. But notice that these are all order book dexes, and that's because Hummingbot, it's designed to trade on order book exchanges. However, I think with the popularity of Solana and Ethereum trading over the past few years, there's been another type of exchange which has kind of gotten in popularity, and that's really the automatic market maker exchange. Popularized by Uniswap on Ethereum, on Aerodrome on Base, and Radium and Orca and Meteora on Solana. So those type of exchanges they function in some ways the same way as order book exchanges, in that they allow makers to provide liquidity and they allow takers to basically trade at certain prices. However, they are kind of like unique in certain ways as well. For instance, they don't support limit orders. Every trade is like a market order, and it's kind of like defined by the smart contract. So you kind of have to like fit the trade parameters to how the smart contract works. In addition, they're all in blockchains as well, of course. So they have to deal with complexities of the Ethereum or the Solana blockchains. And so because of when we started integrating to the exchanges with Hummingbot a few years ago, we realized that it didn't make sense to build those connectors directly into the client like this. And the main reason for that is because a lot of these connectors, like Ethereum based dexes, they have a TypeScript or a JavaScript SDK. And this SDK is usually helping you identify like the best route, like the best pool for a certain trading pair, trade swap combination, something like that. But it's basically kind of like doing a lot of heavy lifting that you don't want to do yourself if you don't have to. So as a Python client, it's hard to kind of like consume a JavaScript SDK directly. So that's why for the first connector we built, I think we actually built a connector for Celo in 2020. At the time, I think we actually installed a Celo CLI client on top of Hummingbot so that you can interact with the Celo wallet and have that CLI kind of talk to Hummingbot. But it was a very kind of like specialized, it was like a custom, like a logic circuit almost designed for Celo arbitrage. So after that, when we started integrating to other dexes, like for Ethereum based dexes like Uniswap, and then also for Pancake Swap and Sushi Swap and other dexes, we realized that you really should have a standalone piece of code, and that should be a JavaScript code base. And now that JavaScript code base can interact with these SDKs, standardize the trading related endpoints, and then Hummingbot, all it has to do is just map the standardized kind of set of endpoints and talk to that one thing instead of having to know exactly how all these other dexes work. Right. So that was the original design behind Gateway. And so that's why we created this Gateway middleware. So if you're running Gateway, for instance, if I say yarn, this middleware is now running. You see, basically, it's exposing the Uniswap and the Jupyter connectors. Now, my gateway says online of my wallets that I've added into Gateway on those exchanges. So it's right now it's fetching the balances. If you look at what it's doing on the Gateway side, it's fetching kind of like tokens. It's fetching the allowances as well. So now I see based on this wallet on Ethereum, I have Ethereum of this, and so basically it's right now it's like it's connecting via every exchange connector, and now it can also run an arbitrage strategy or some strategy that's using that exchange. So that's the original kind of purpose behind it, which is kind of like Gateway is a piece of middleware that standardizes DEX kind of endpoints, consuming those libraries, and then allowing something like Hummingbot to interact automatically with these DEXs. Okay, so but let me just take you through exactly kind of from a technical perspective what we're doing right now with Gateway. So currently the main branch of Gateway is the one that is installed when you launch Hummingbot, in the last release. But we're working on a kind of refactor branch called Core, and the reason behind that is because when we first built Gateway, there's actually kind of a few blog posts I think on Hummingbot that explain the motivation behind it. Let's see, I think it's in engineering. For example, here's a couple of blog posts on our blog that our original CTO Martin wrote, and these kind of explain the thinking behind the Gateway project from an architectural basis. But when it came to actual implementation, unfortunately, there were just a lot of unknowns back then. So when we first designed Gateway, this was before we had kind of like the standardization of L1 versus L2 networks. Even back then, it was just blockchains, and so right now, for instance, if you look at kind of like there's a lot of kind of nested code here because we're trying to account for all these different possibilities in terms of like what what these guys can do. And so that's why there's a lot of, yeah, actually, I think especially on the connector side, AMM side, basically the existing structure has a lot of like structure that was built in before the market kind of like actually standardized into the blockchain ecosystem that we have today, where it's really kind of like EVM and Ethereum based networks that is standardized at a chain level, but there are some nuances in terms of dexes, but the chain level is very much, everything is just using EVM, and then with Solana, I think it's also kind of like the other kind of like the minority kind of architecture, which is also gaining prominence, where I think a lot of, and you're also seeing kind of like the SVM used as the basis for other networks going forward. So I think it's kind of like having this like base chain with a certain network on top of it architecture is the right one, but I think we can drastically simplify a lot of what we had in the existing gateway architecture. The other thing I think that with gateway, because it tries to kind of like do a bit too much. I think now I think we're in a better position to understand what gateway, the areas where gateway should be imposing constraints, and the areas where it should be offering flexibility. And so I think right now what I'm doing is I'm basically just taking this code and really more like reducing it, focused on the Uniswap and the that's one of the files I removed. So this core branch here essentially has the latest kind of like the code. So it's stripped down and it's really just focused on the on basically the Ethereum and the Solana chains. So right now there's two folders for for Ethereum, and then there's a folder for Solana for chains, and then for connectors there's a folder for Uniswap, and there's a folder for Jupiter, and then the set of wallet routes and kind of config routes. But overall, it should be basically installed the same way as how Gateway is used today, but it should be a little bit cleaner to use. So the thinking here is that I think I'm still in the middle of the refactor, but it should be done by the end of this month. So what's in the next release of Hummingbot, which is the end of this month, should have basically the updated, fully fleshed out, like a refactored gateway. But that fully refactored version should be be cleaned up, and it should have like the connectors for Uniswap v3 and Meteora. Because right now, it supports Jupiter and Uniswap already. So this is kind of like functionality that we currently have in Gateway, but we should also be able to add new connectors for the LP endpoints and add back kind of like the V3, kind of some basic LP endpoints at least into Gateway. But let me show you how to kind of install and use Gateway this right now. And that way you can already start using it. You can already test out the core branch of Gateway on a standalone basis, or if you want with the PR and Hummingbot that uses it. Okay, so if you have any questions on kind of like what a gateway is supposed to do or along the way, just drop it in the chat and I'll try to answer it. Okay, all right. So in order to set up, if you're starting from scratch, you would probably just clone the gateway repo. So I've already cloned it. So actually, sorry, this is the Hummingbot repo over here. So yeah, this is the gateway repo over here. So basically, a repo that you want to go into, let's call it like a temp, and then let's see, So then you would just basically go to gateway like this, and then you can just clone the gateway repo. So I use SSH. But I will clone the SSH like this, and that will just copy the files from this repo into my local folder. So it's going to fetch all the branches. That's why it takes a bit of a while, but but after it's done, then we can check out the core branch and use the code in it. So that's the gateway. So then here, once you're in main, you can just check out core, and now the core branch. This is. Let's first install the dependencies. Actually, so basically to do that, you would basically just do. Actually, I'll make this a little bigger. So you can just do yarn. So yarn will install the dependencies. This is just basically creating the node libraries that it uses. So downloading the files there. All right, so then what you can do is then you can run yarn build. So that builds the actual JavaScript files from the TypeScript, and then finally you can run the gateway setup command. So the gateway setup command is the one that allows you to basically it creates the configuration files and it also copies over the client certificates from your Hummingbot instance. So I am going to copy over my client certificates, and so my Hummingbot folder is I'm going to go to my Hummingbot folder, the one that I want to use. So I already know what the certs folder is here. So it's here, and so let me just get that file here, and then I'll copy that in here. Okay, so now it's going to do two things. The first is going to copy the certs from my Hummingbot folder into this newly created certs folder. So that will allow Gateway to use the same certs as Hummingbot, and then it's also going to copy the configs over from this templates directory into the newly created conf directory. So this conf directory is important because this is the folder and the files in this conf directory are what we're going to edit in order to change how Gateway is configured. So let's proceed, and it will complete its actions. Okay. So notice that it's basically copied the files over into conf, and it's created the source as well. So all right. So let's go and actually code or any IDE to check out the files in this folder here. So I'll use this here, this. So I think here's the folder itself. So let's take a look at this conf folder and see the files in it, and because I think we'll be editing these files here. So these YAML files are your configuration files for each connector and chain. And the server YAML is the one that kind of controls like the base. This is like the configuration for Gateway itself. So this file is the equivalent of like the conf client file on the client side, because this is the one you'll be editing. So notice that there's a few things here. You can set this first one is important because this is what you'll be using to set whether to run this in kind of development mode, where you can just like check out the routes and use this HTTP, or in HTTPS, where it's like secured behind all the endpoints are secured, and that way Hummingbot is designed to interact with it, because Hummingbot, that's why the certs are there, is to allow Hummingbot to talk to Gateway, even if the endpoints are HTTPS. Some other parameters that are important are like this helps you make sure your log time is the same as your local time. This is a port where Gateway will expose the API endpoints. Here you can define a different port, but yeah, I usually set to 0 because then the documentation where we'll be interacting with endpoints will be hosted on this server /docs. So the reason we do this is because if the docs are, and if you basically have the server running HTTPS, then the docs port you probably need to set it as a different URL in order to expose it, because otherwise it'll be under this HTTPS server. Okay, so other things are, yeah, this is where your certs are stored. This is where your logs are, and some other actions as well. So in order to run it, so you can just run it like if you want to be true. So notice that this is running in development mode, which HTTP endpoints, and so the server is running on this server here, which is this port, and then you can go to the documentation like this on the docs. So let's open up a browser window and then go to that server, and so this will show you all the endpoints that are available in Gateway. So in the old version of Gateway, actually in the current version of Gateway, we didn't have this because this is a new feature of having moved to Fastify. But now you can just interact with the endpoints like this, and just let's see. Here's available connectors. So this connectors endpoint provides a list of the available DEX connectors and the networks, and you can basically just check out what the format of this response is. So this response is used by the Hummingbot client. So the client is already interacting with Gateway. So the main way we'll be interacting with Gateway is through the client. But I want to show you this because you can also interact with Gateway on a standalone basis. And sometimes it's helpful to do this in order to see exactly, debug any issues you're having with Gateway, or to kind of interact with it on a standalone basis if you want. So this config route, for example, shows you if you don't add an option here, it shows you basically all the list of configs. This configs is basically this is essentially a big list of all of these configs here, which are the configs for each chain or connector. But notice you can also specify. Let's say I put in Solana here. I can just get the Solana specific configuration as well. This wallet routes, these routes will give you your wallets across different chains. So, for example, this one is empty because I don't have any wallets here. But let me add a wallet. Give me 1 second while I kind of figure out how not to expose my private key. 1 second here. Actually, I probably need to move this to a separate window. So I'm gonna call this this add wallet private key example. So I'm gonna add my Solana wallet, but let me do this off screen so that I'm not exposing my private key to you guys. 1 second. 1 second. Here. Oh, yeah, what is going on here? Oh shit, what's going on here? I think give me 1 second. I think I know what the issue is, but okay. All right. So yeah, okay, got it. Okay, that's fine. It looks like I'm just signing off from all my accounts, which happens when you're always doing this. Give me 1 second. So. Okay, almost there. All right. Okay, 1 second. I'll probably edit this out of the video, hopefully. Okay, done. Okay. All right. Looks like I need some more testing with this function here, because it looks like I was not able to add a wallet successfully here. What is going on? The private key has to be private. Okay. All right. That was unsuccessful. All right. So let me go back to let me actually go back to the. Oh, actually, that's probably because of the HTTPS thing. So yeah, I should probably test this more cleanly, but let me do this. But let me do this a different way. Okay, so we can also test this with Postman as well. So if you basically set this to false like this, and then also run yarn start. Oh yeah, so now is generated in Hummingbot. So because I know that I generated the certs with password A, I can do like this. But usually if you're gonna do this, you would need to generate the certs from Hummingbot, and take that certs file and use the same passphrase you generate with the certs and use it here. But because I know I generate the certs using the passphrase A, I can do it this way. So yeah, the reason that failed is because the certain routes, I think all the post routes expect it to be behind HTTPS. So that's why we need to probably address that when we have the Swagger docs available. But yeah, one of the changes we're making is essentially so that you don't need to have you can interact with Gateway on a standalone basis using HTTPS. And you can also interact with it using HTTP if you want. Sorry, what I meant is you can interact with Gateway on a standalone basis using HTTP if you want, just using the Swagger docs. And then also you can also turn on HTTPS like this, like what I just did. And now it's running all the endpoints the same way in secured mode. And now you can only interact with it with Hummingbot, the client, or if you want using Postman. So Postman. This is Postman. So Postman is what I've done here. Postman. I've already done the setup where you can go to settings. And you can add. You can add the certificates here from your gateway. But yeah, if you haven't done this already, then I think I should do this in a prior video as well. So yeah, actually let me actually do this. I'll set up from scratch because I do think that I probably haven't done this in a while. So I'll set up from scratch just using this one here and Postman, so you can see how to interact with it using Hummingbot and with Postman here. Okay, so actually, yeah, you know what? Never mind. I did do that in a previous video, and I kind of like it is a little risky to like just delete all your certs and start from scratch. So I'm not gonna risk that in this video. I think there's a previous live stream I did about a month ago where I did walk through the installation steps for Gateway. It's actually the exact same. Nothing's changed. So please refer to that if you want to learn how to connect Hummingbot to Gateway, set up the certs, and then copy the certs over correctly. I want to demo like the actual arbitrage on Solana and on Base. So I'm gonna save the demo gods for the important stuff instead of this stuff here. Okay, all right. So let me actually go to the version of Gateway that is not in the temp directory here, that I have here. So let me first show you, so which is the same thing I have here, just the actual version of Gateway. So let's see if I open Gateway here. Yeah. So this Gateway here is the one that I've been working on, and so yeah, this is already updated in the core branch. But what I want to show you is basically if I run this this configuration here. So I'm gonna run first. First, this is in let me run this in true. So now it's running in HTTPS. HTTP. HTTP. Sorry. And then I'm gonna run it with yarn passphrase equal to A. And then so now I'm gonna go to the Swagger docs, and now they should be working correctly. So audio is pulsing, but maybe on my end. Okay, that's probably on my side. So okay, so basically once you've done this, this should work. And now, so now let me show you the list of wallets I have. This set of wallets, essentially, this matches what I've added into Hummingbot client. So essentially, when this is running here, I can access it through HTTP like this, and this helps me just kind of like I should be able to interact with all these endpoints directly if I want. I can see the status of Solana, for example, like this, and see. So this will tell me the status of the Solana connector, and then I can also run the same route for Ethereum, and I can pull. Hello? Hello? Okay. 1 second. Let me just look at the sources here. Hello? Hello? Okay. I think sound's working still. Okay. All right. Okay. So basically what I'm saying is that essentially we'll have these status endpoints here. So that basically we'll have the same status endpoints for Ethereum and for Solana. But these are actually doing two different things, because the Solana status one, this is fetching information from this RPC URL. So it's getting kind of the timestamps, the latency, some other stuff here, and then for Ethereum, it's fetching data from this RPC URL here. But I mean, overall, the goal is to have essentially the same routes for different blockchains, but these routes should return the same responses, but do different things under the hood that are specialized for each blockchain. So and how you control that is defined in the configuration files for each blockchain. For example, for Ethereum, the main thing you want to define for Ethereum is kind of like what the different networks available are, I think, and how you control and connect each one, because each one even the EVM chain is the same. What's different is maybe the node that you're using to connect to it, and also the mapping from the addresses to tokens that you're using. What's also different might be other variables like how often you refresh the gas, the native currency symbol used on the chain, and so forth. So I think these are we think these are the right parameters, but I think making it available for people to add new ones over time, I think is also the goal. So that's why we have a different set of configs for Solana, where these networks are important. But I think in terms of using the Solana blockchain over the past few months, I've also learned that you also want some more fine-grained control over how you set your fees, especially your priorities fees, because the Solana blockchain is very volatile. Depending on the program that you're interacting with, the fees for interacting with it might be very different, because essentially the fees depend on how much competition you have from other market participants accessing and locking up that block space for a certain number of blocks. But each block in Solana is like a second or something like that. So because of that, the fee per block can vary quite a lot. And so what we found is a format where it's like ideally you want to fetch the latest fees paid from your node. I think then you want to use some percentage multiply, basically some percentile, to say, do I want like the average fee, or do I want to make sure my fee is like more than 90% of the fees? But that's what this fee percentile does. So by default, we're using a number which is greater than 75% of the samples that you're fetching from the node. And then from that you can apply essentially, I think you want to try to send transactions at that base fee level for a certain period of time. Once that period of time is met, then I think you want to step up that fee, try it again, step up the fee, and try it again. And I think that process, that pattern should ensure that you're hopefully paying the lowest fee while ensuring your transaction gets through with some amount of time. So, but I think the user may want to change these defaults, because certain people may value paying a higher fee, to get transactions in faster. Others may want to be willing to wait longer. And so I think using these parameters, you can express those kind of views. For example, you can set the multiplier every time you step up, how much you increase the priority fee by. These retry intervals are how much you retry at a certain level. So for example, your initial level, you'll try 10 times and wait 5 seconds, and wait 0.5 seconds every time. So essentially you spend 5 seconds at level 1, step up, and then 5 seconds at level 2, and so forth. But you can change the number of retry attempts as well as the interval here. And you can also set the minimum and maximum priority fees. So the minimum fee is basically how much in land ports, which is I think 1 to -9 sol, you're paying minimum and maximum. So essentially, this just helps you bound how much fees you're willing to pay to get a transaction landed. So in terms of pure Solana terms, so this number here is 10000. This is basically. So this is basically this times sol. So that's about something like so that's basically 0.2 cents, I think, and your maximum fee here, which is 2 million divided by 1.9 200. Oh yeah, so your maximum fee is 0.4 cents. Because it's 2 million land ports, which is about divided by 189 to get the amount in sol, multiplied by the price of sol, about 0.4 cents, and the minimum fee, which is 100,000 land ports here, is about 0.02 cents. So here's an example of how we can just use it. So I'm going to pull Postman here. So Postman, I've connected the certs already. So here I have environments for Solana, base and mainnet. So basically these collections here, Basically this just has some variables for kind of what the host, chain, network, and keys are. So I've kind of set these already. So I've set collections for Solana, base, and then Ethereum, and basically the main differences are just basically the which connector I'm using, which network, and also which wallet and so forth. So let's go ahead and fetch basically fetch a price for a trade and try to see how to use this thing. So the first thing I wanted to make sure the gateway is running. It is. So right now it's running in HTTP mode. So I'm still working on the Swagger docs, which what I mean is so basically I think the way that you should be able to use this over time, or not over time, like basically when in the next release, is just interacting with the Swagger docs like this, and basically just interacting with 8 endpoints when it's under development mode. However, the secured way to do it, which is having it under HTTPS, should always work as well. But it's just what I found is it's a little like more cumbersome to work with. But I think at least right now it's kind of like the easiest way to do that if you just want to just interact with it right now. So so now it's running HTTPS. So what that means is I can interact with it using Hummingbot like this, through the CLI in Hummingbot, and I can also use Postman as well. So first I can use it with Hummingbot because I've already connected the certs here to here, so I can run gateway and basically a set of commands here. So for instance, test connection, that pings the status function here. I think over here. I can also ping, say gateway, say connect. So yeah, this will show you the the list of connections that are available and the wallets that I've already connected. And then also I can see check gateway balance here. So the gateway balance takes a while because it also fetches the allowances for these different assets as well. So there's certain things we want to separate some of these commands, because all this stuff is doing is just calling different endpoints on the gateway middleware. So because of that, I do encourage anyone that's using gateway to basically access it on a standalone basis, just to understand what it's actually doing first, because sometimes, like, if you interact with the Hummingbot, it kind of hides some of the things from you. But so that's also a change that in the future we should make the connection a bit more seamless, where what you're seeing with Gateway is also what you're seeing in terms of the responses in Hummingbot as well. So for now, I would say, my goal is to have this Swagger UI be usable just like Postman. But right now, I think once you run in secured mode, you can use Postman to interact with endpoints in the same way. So for example, the balances endpoint that we just called, I can also just call this balances endpoint directly. And you notice this chain is now in the URL instead of defined as a parameter. So this makes it a lot easier to have a single route like this, and kind of, and essentially have different routes for each of the chains, so that this introduces a bit more flexibility into it while retaining the same route structure that Hummingbot is available to it. Okay, so basically, let's take a look at my environment. Make sure I select Solana as the environment, and then go back to balances. So now when I run this command here, I should see my balances for Solana and these chains. Now, notice that I do fetch this M3 token. This is a pretty new token that recently came out, and so sometimes new tokens may not be available to your list. So let me show you how to add a new token to the list. This is something that people have always kind of asked us. We actually might add this to the route, but for now, I've added a new add token script into this. You may run to kind of like configure like permission issues with it. So if you have any issues, just do like hmod 755. That makes it executable. So now I should be able to run it. And then so now I'm going to try to add a token to the Solana list to be able to access it using Gateway. Because right now what's happening is in the first step, recall the first thing we did was we ran the Gateway setup command. That setup command not only created these config files, it also copied over the lists of tokens that are used for basically to map kind of addresses to the right information, like in terms of like what the decimals are for the token. So basically, this information here is essentially the information that you kind of need for basically for each kind of like token that you're trading. So all right, so essentially, this information here is what's contained in these list files. So let's say you want to add a new token. Maybe it's a new meme coin, some new thing you're trading. So actually, let's pull up a token here and try to add the token and see if we interact with it. So let's see. Let's pick a token that's pretty active, but it's let's say like this. So yeah. Let's pick this one here, this A16Z token. So this one I think is pretty pretty hot right now or something. So let me copy the address, and then so first I need to add the list to the token list. So let me pull this up in SolScan first. Okay, all right, we have the token. So first I'm going to add the token, the list, the file. So that file is going to be in, okay, So it's this with Solana.json. So it's like this. All right, so first we need the address. So the address is right here. Oh, okay. All right, that's I need to remove that check because I think I only tested this for Ethereum. Give me 1 second. Jesus. Okay. All right. Let's try that again. File. All right. No error. Good. Okay. All right. I'll commit that change later on. But yeah, this is the value of live testing and prod. All right. So symbol is going to be this one, I think. Enter. I use the same symbol. And decimals, this is important because this helps get the thing right. So this is 9 decimals. All right, so basically it's to add a new entry to the Solana mainnet chain, which is chain ID 101, address, symbol, and so forth. And then, yes, I want to proceed. Okay, so now it's added that token to the list, and we can verify it if we go to the conf list directory on Solana. We can see at the very end, indeed, there is a new entry for I16B there. I think that add token script also checks for duplicates. So if you try to add a token that's already in the list, I'll try to prevent you from doing that. Okay, so now that it's in the list, we can restart Gateway again by running the same thing. And now, if we have any of that token, we should be able to query for it in this balances. AI16Z. Is that the right name? AI16Z. Yes. Okay. So now we can send, and we don't have any token. Is that? You know what? Jesus Christ. Yeah, I think that is. I think it's because I don't have any of the asset. I think. This should query. It's possible it's the. I haven't actually fully tested this with like capital letters and everything, so it's possible that it's not. Yeah, it's possible to do this right. Yeah. Right, yeah, it's possible. I think maybe I have 0 balance. Let me try buying some. Actually, we can do this as a test. So let's use the trade function and purchase some of it with this, and we can basically see if it does actually purchase or not. So first, let's look at the price. So what is the price of this thing right now? So it's $1. Okay, so that's actually kind of expensive. All right, so let's buy something like 1 of it with Sol, and see how if we get an accurate price back from the Jupiter connector. So this is actually calling the Jupiter /price endpoint, and it's passing in basically on Solana, and it's passing in A16Z as a base, Solana as a quote, and the amount 1. So basically what we're saying is giving the price to buy 1 A16Z. Okay. So that doesn't work. Let me check. What is it doing? So yeah, for some reason it's not. This thing is not working for some reason. So okay. So let me actually try this. It's possible it's because of this naming thing. So let me try it this way. I think this is definitely working. A I16Z, like this, like that. Okay, so let me try it that way. Yeah, I should probably do more testing on this add token feature before trying to do a live stream on it. But hey, it happens. So let me just build this first as well. Make sure we're actually have the right repo, and then start. Okay. So yeah, I don't see a reason. This is improperly formatted JSON. No, this looks like the right JSON. Okay, so I don't see why my token is not being found here, but I will try to find out. Nope. Okay. If I do this. Okay, wait. Okay, no, something's going wrong overall. Okay, sorry. Oh, what's going on here? What's going on? What is going on? Hey. Okay. Jesus. Okay. Let me go back. I don't know what's going on here. I don't know why I can't do anything anymore. Okay. Let me go back and try yarn build. Okay, reset. Jesus Christ. Okay, HTTPS. All right, let's get into configurations. So yeah, I don't know why this is not working. Okay, I think I must have screwed up something with the add tokens command. Is that's the only thing I can think of. So, okay, so this actually just redoes the lists, and I'm gonna do that, and that I feel like this should work. It's unfortunate. Okay, all right. Let me try something else here. Okay, so that works. So it's fetching the correct balances from Ethereum. Yep. So yeah, this is indeed my correct base balance, USDC balance, everything. So how come it's not doing this for Solana correctly? Let me see. Okay, so now it's working. So that works. So what does not work? This price endpoint does not work. Okay, no, that works. Okay, so yeah, something happened with us adding new tokens in. This price that's probably something I need to check. But basically, yeah, you should be able to add new tokens into the list. Actually, let me try to do it manually. So I do want to verify that it does work. So let me actually take that token that we're trying to add and just add it manually into the list here, because I think it might be something where it's like, oh, you know what? I do see this actually looks wrong. I don't know why this token has a 0 decimal. So that's actually just does not look right. But okay, so if I do it manually, I can just add a token at the very top of the list, and let me add that A16Z token, because I want to make sure we actually can trade new tokens into the list. So I'll add like this, so add like this, and then I will add it like this, 9. So the address is like this, address like that. Okay, so that adds a new entry into this list, and so I just want to make sure I can. All right, so now I think at the very least I should be able to query for it here in balances. Okay, or at least like fetch a price for it. Yep. Okay. So that works. So yeah, I think there's an issue probably with that add tokens script that was like screwing up this file in some way, because so now what it is is I just manually added that in and it works. Let me actually go and actually purchase a small amount of this thing. I'll buy it actually. Actually, not 50. 50 is too much. That's like more than $50. So how much is it buy one? Let's see. Interesting. Oh, interesting. Why is that? because you can't buy one that way. Oh, okay. Okay. Yeah, I need to look into this. This is definitely concerning. Sell. Because the sell endpoints don't work. The buy and sell endpoints don't work. Yeah. Okay. Got it. Yeah. It must be the buy and sell because the buy endpoints. The buy endpoints are using exact in. So the swap, the sell endpoints are using exact out. So yeah. So there's some nuances here in terms of like the buy and selling because some of this is not quite as simple as just setting orders on a sex. Yeah. This is an example of there's probably I need to figure out what this error code is. Is it if it's a actually is this a swap issue? Yeah, it looks like this is probably not. It's not getting the right swap object because it's not even sending the response. So yeah, this is actually interesting. Anyway, so basically what we found is depending on the token you're trying to trade, there might be just different issues. So if you're trying to trade something that's like highly congested, like this token probably is, there's probably more issues. And my guess is it's probably a slippage setting is probably why we're seeing that. Actually, let me do that. I bet it's my slippage setting. Second. So so slippage is actually set over here in the Jupyter one. Here, this is a fraction that you can use to basically define your slippage. And I think if I use, let's say, 5% here, that'll probably resolve some of these kind of issues, is my guess. Let me try it again. Okay. That is unfortunate. What's going on here? Yeah. Yeah, there's some like weird bug I need to resolve here. I think it has to do with initialization, because if I do like this, no. Yeah. See. So yeah. I think it's an initialization issue that I probably need to fix before pushing this code fully on development. But basically, once the connection is initialized, you should be able to fetch prices for any token. And what it's doing here is just passing the base and the quote into the Jupyter API using this slippage setting and fetching kind of like what Jupyter thinks is the right price. So basically, what it's saying is, if I want to sell one AI16 Sol, then I'll send one of this token in, and I will expect to receive this amount in Solana back. Yeah, actually, I think this actually shouldn't incorporate the fees. The fee is basically this is the fee assumption here. The fee is going to cost this amount in gas. So let's actually go ahead and actually try to see that if that happens. Actually, let me do a buy. We actually don't have any of this token, so let me try to do buy and see if that returns. My guess is the prior one was, this still doesn't return, because it's the number. Yeah, so I need to figure out why this buy route does not return. But in the meantime, let's use a different token that I already have. So I have some of this M3 token here. So I want to. We can use this one as an example because I just want to show how the API works in terms of actually executing trades on Solana. So if we use this M3 token, currently I have, let's see, so currently I have 158 of the token. Right now, the price, if I wanted to buy, let's say 10 of it, is something like 0.003 Sol. So the current price is I think like pretty low. It's like 0.007, yeah, about 7 cents per M3 token. Actually, exactly 0.069 is a price, ladies and gentlemen, for M3. And so we can go and essentially just basically see how much is to buy 10 of these. So this should be about this much in Sol. And then now let's go ahead and actually trade it using the API as well, like this. So we can also trade it. Let's see, so we'll buy the same amount here. And so so when we trade it, you can see that whenever every few seconds, the gateway is talking to the Solana node and fetching the current gas price. So basically, what it's saying here is that based on the last few transactions, people were paying about 500,000 micro lamports in terms of gas priority fee. And so if we were to send a transaction today, this is how much it would cost in Sol. This should actually be Sol here. Okay, so let's go ahead and buy. Actually, let's fetch the price again, because sometimes it'll update the gas fee. It's still saying, here's the current price, here's the gas cost. And so let's trade exactly that as well. So when you trade it, what it's doing is it's gonna send the swap with this current priority fee. And if it'll try 10 times at the retry interval of half a second. This time around, it got confirmed in the first attempt. So this time here's the transaction. So this is the transaction hash, and we can also just directly use the pull function here to fetch the transaction receipt and see the details. So we can see that the transaction receipt was indeed 1, and here's the data. The fee actually didn't match exactly what we paid. Because we can also go to it in SolScan and find the transaction. So here, we purchased 10 M3 using Solana at this price, and we can see the price of the fee was indeed 0.02 cents. This is exactly what we estimated in here as well. If we want to reverse the trade, we can just do the same thing, and we can price a sell trade here as well. So the sell trade, same thing, and then we can basically trade it here using sell as well. So I'm doing this because essentially these are the same API endpoints that the Hummingbot will be hitting when you're doing arbitrage. So when you're doing buying and selling, it's just basically fetching the price for a $10 buy order or $10 sell order, from essentially Jupiter, or from Gateway essentially, and then if it decides that there's sufficient profitability to actually execute the trades, it will just execute the trades on exchange 1 and on exchange 2 automatically. So let's do a sell trade. So this is it's selling 10 M3 for Sol. So this time around, it's also it fetched the priority fees, and then once again it succeeded in the first attempt. So actually, let me actually rate, since we did this again. Let me actually try this again. I'm gonna stop Gateway, and I'm going to change the configs here, so that we're gonna kind of try hopefully test out the retry mechanism a bit more. So to do that, I'm going to change this percent to 25. So now we're fetching, actually, I'll use 75 again. I'll still use 75, but I'll start with a lower priority fee of 10,000. And then I will also increase this multiplier to 1.2. So now what I did was, I'm going to start with a lower base fee. Actually, I'll start with 10,000. So what this does is it starts with a lower base fee, and hopefully that will allow us to test out the retry mechanism slightly more. All right, so it's running now. Okay, so let's try this trade again. Let's make sure it balances. We still have 160 of this M3 token. So let's just try trading. Let's sell 10 of it. Oh, okay. So immediately we can see that we did try to step up the swap, but now we're seeing this too many requests error. So the reason we're seeing this is because we are using we probably need to build some more intelligent retry mechanism in the gateway, but it's also because we're using the default node here. So I'm going to go and change this to my own kind of personal node, like a quick node that we have. And the reason I want to show you this is because a lot of the issues that you could be running using Gateway are probably related to the node. So by default, this is like the default node that people use when they use Solana. However, if you are running, some type of some other trade, you probably have a need for other nodes. So let me just pull up my other node, and we will. A second, what is going on here? Okay, sorry, my OBS is interfering with my other network streams. Give me a second. I'll pull this from my other location here. I don't know why. Here we go. Okay, here we go. Okay, so I'm going to change the in Gateway. I'm going to update my Solana configs to use my own private node instead of the default node, and that should actually resolve this 429 error that we're seeing. So it's in conf. I'm sorry. This is this is part of what's confusing. That was Hummingbot, not Gateway. So here's Gateway, and then conf Solana. I'm going to change this to node URL, and I'm going to copy this instead. All right. So now I'm going to start Gateway again, and now let's try this again and try to see how many retries, how low we can do a swap for. Oh, okay, what is going on here? Yeah, this is that config issue that I need to resolve. There's something when I switch environments right now, I think, and I do like this. Okay. This is the, I think about it. For some reason when I do a balance check like this, then this kind of works. Yeah. All right, yeah, I need to figure out the initialization error later on. But anyway, so let's try this. Let's sell 10 and Ethereum 3. Ooh, swap API post attempt. Okay, interesting. Okay, all right, yeah, that's interesting. Sometimes the swap API, the Jupiter swap API might be sometimes like when it's busy like this, this might happen. So let's try that again. All right, so let's see. Okay, so now it is increasing the fee. So let's see if it will work. So that was the second time. So this is the third time. Okay, so yeah, now so basically it probably tried a total of like 10 or 20 times, and the third time it increased the fee, and we did actually get a swap across. So let's take a look at this transaction hash here. And let's compare this one. This one was the one we did before, where we did a swap for 2 cents, and then the new one. Oops. Okay, so this is one we just did, and notice that for this one we paid 0.005 cents. So the reason we did that, just to recap, was we got a better node, so we can send more requests to the node. We lowered this priority fee from 2 to 1.2, and then most importantly, we also lowered our minimum fee. Before, our minimum fee was 100,000, and we actually lowered it to 10,000. And so that meant that it was essentially starting from a lower base. When it was that. So essentially, there's a trade-off between how quickly you want to get the transaction confirmed versus how much fees you're willing to pay in terms of fees. And these settings, I think, allow you to control that for Solana. Another important setting is going to be this slippage setting here, because this is a setting that you're passing to Jupiter, in terms of fetching the price. So basically, the way it works is you fetch a route that is basically the best route that allows you to achieve a price given the slippage. So if you want to have a lower slippage, I would encourage you to something like like this even. But this setting here, I think, should be similar to what you're sending when you are using the Jupiter API directly. Let's say Jupiter app directly, because even when you do a swap over here, there's a certain there's certain kind of slippage setting. I think like over here, I think here this is where you're setting the slippage mode. So a lot of this is you're letting Jupiter manage it on your behalf. But in Hummingbot, because it's Hummingbot kind of exposes everything for you. So basically, in Jupiter, essentially what happens is, when you send a swap, you're basically assuming a certain level of slippage, and so you can define that in the Jupiter YAML config file. All right, so now that we know how to do that, let's see it in action with Hummingbot and see how that works once you're actually trading. Okay, so I've already set up a file that's going to run using the arbitrage controller. So in Hummingbot, we have we have different controllers for different types of strategies. One of them is the new arbitrage controller. So in this configuration configure session, I have a few configs set up already. Here's my Solana config, and here's my base config. So let's run this one first. This is the Solana config. So what this strategy will do is it's going to try to arbitrage between KuCoin and Jupiter, and it's an arbitrage between the M3 USDT pair on KuCoin and the M3 USDC pair on Jupiter. For each arbitrage leg, I'll use basically three USDC as the order amount, and I'll try the arbitrage simultaneously. So essentially, I'll try two arbitrage attempts. One is to buy on KuCoin and to sell on Jupiter, and the other leg is to buy on Jupiter and sell on KuCoin. And so for each leg of the arbitrage, it's going to try to trade, total of 3 USDC for each leg. And it'll do a trade if the profitability is greater than -5% or higher. And the reason I did this is more to just actually make sure we get some trades. I probably wouldn't set this normally, but I'm doing this just to kind of show and to verify that the connector actually works properly. So one of the settings here are, this is basically, because this is how long it waits after completing arbitrage before doing another one. So you can kind of, so you don't spam the network with arbitrages, even if it's profitable after doing completing one. And finally, this final setting is how many buys versus sells you can have that are in balance, because you can have this. What this means, you can have like 5 buys, but then you're not going to do another 6 buy before doing a sell to keep your ratios of inventory more balanced. Okay, so those are the main settings for the arbitrage controller. But this is a V2 strategy, and so we've basically been migrating a lot of our strategies to V2 in order to give users more flexibility and power in running them, because you can run this using the dashboard, and you can run multiple instances of this controller using one single script, which is going to be a lot more powerful in the future. All right, so to run this, I've already set this up so that this script is being loaded and run by the generic loader script. Basically, so anything with this config, if I run the loader script with this configuration, it's going to pull up. With 1, it'll pull up the Sol one. This 2 will pull up the base one. There's probably a more easier way I can do this, but this just allows me to run it using the quick start command easily from the code base. But basically, if I just do like this. Not like that, like this. Yeah, if I just run this bin quick start command with 2 at the end, this will run base, and if I run 1, I'll run the Solana one. So I'll run the Solana one now, just to see how it works. Okay, so let's hope that this works. Let's see. Actually, this is still running. This is using my. Actually, you know what? Let me start this over again, because I'm gonna start with a clean, fresh code base, because I was doing some testing earlier. I also want to make sure that my gateway settings are good. So yeah, now I'm gonna allow 2% slippage here on the gateway side. Yeah, I'll make sure I increase my fees. So 2, okay, and then finally on the Hummingbot side, I'm going to delete anything I had before. So, oops. Okay, all right, ready to go. So now we have a clean, basically clean version of Hummingbot. You know, right settings for gateway. So now we should be able to run some arbitrages. So let's see. Okay, should be able to ignore those Binance errors because that's just a function of me not, you know, being in a Binance accessible country. But that's not used in the strategy. So that shouldn't be handled. So yeah, it looks like it's already done one trade. It's bought at KuCoin and sold at ooh, this is interesting. I got an error here for some reason. Why am I doing error? Insufficient balance of base token. Ah, okay, got it. So yeah, this is probably an error that we should handle better. But let me stop this bot and exit here. Yeah, but before I do that, let me show the error. The error is because I just don't have enough of balance of M303. I think I did at the very beginning, but after this trade happened, I didn't. So that's because I only have something like 14 of M303. I was trying to sell something like 45. So this example where unfortunately the error handling between Gateway and Hummingbot can be improved, and that's one of the things I plan to improve in this refactor. But yeah, in order this is more because this is like $1 worth of M3. So this is really for testing purposes. But if you're in your arbitrage, you probably want to make sure you have enough of either side. I should make sure I have enough of that in the KuCoin side. So yeah, I do have looks like I have like something like $80 worth of M303 over here. So let me just go ahead and use Postman to buy some more of M303. So it looks like I have 14. Yeah, that's probably too low. Let's go buy like 100 of it. Actually, probably need more than 100. That's like $7. Okay, so let's buy more than $7 worth of M3. Let's buy a grand total of $14 of M3. Let's see. I'll monitor the trading like this. Let's trade. Setting the swap. Oh, it's actually using a pretty low fee here, but we got it confirmed anyway. Okay. Didn't pay. Oh, actually, that's actually a very low gas cost. I think. Let's see. Yeah, pretty low. Not bad. Okay, good. So we should have more of this. Let's check the gateway balance again. I think I'm going to remove the allowance check from this actually, because right now it's checking for balances and allowances, which is why it's taking longer. But it's probably adding too much complexity into that function call. So yeah, so now we have more M3. So now I'm going to exit the bot, and I am going to clean the files again. So we start from scratch. We really start from scratch. And then hopefully we'll have a clean start to our arbitrage experience on Solana. Okay. All right. So let's try that again. running the bot, and it should hopefully work this time. Okay, so here is it creating the buy order on KuCoin. Here's the sell order on Ethereum 3. So we should be able to just let this run for a little while, and it should do its thing, I think. Done 3 trades here, so yeah, it should. Now I think the other trade should have filled. Okay, so now it's complete. So now it's basically the volume that's doing on KuCoin should match what it's doing on Jupiter. So obviously, you probably wouldn't be running this, and losing money all the time. But I'm doing this because this is more for quality assurance purposes. Anyway, so I think I've tested this enough to I'm pretty confident this works, fairly well for non-congested pools. I think if you're doing this on kind of new tokens where there's a lot of congestion, running this strategy is probably not going to work because there's going to be edge cases that the strategy is not going to handle well. For example, if slippage is too low, or if the order isn't filled in 30 seconds or something. However, I think that if you want to trade kind of like these more congested pools, I do think you can kind of customize the gateway settings using the Solana YAML file and a Jupyter YAML file to trade it directly. And I would actually just use Postman directly to trade instead of trying to use Hummingbot. So here what happened just now. But right now a swap failed, and so we can see. Oh, actually, okay, this is actually an insufficient balance issue as well. So it sounds like what happened was we traded 200 M3M3. We bought on KuCoin, we sold on Jupyter, and now we ran out essentially. So yeah, so we probably need a better mechanism in this. This is actually probably more on the strategy, honestly, than on the connector. But the connector and the strategy probably need to talk to each other a bit more in terms of what's actually going on, because right now on the client side it looks like it's just failed, and here if I look at the strategy logs, it's clear that it's an insufficient balance issue. Okay, but I think we have some work to do to kind of make the strategies kind of better. But I think the connector, in terms of just being able to execute trades at different fee assumptions, should already be present in the Solana connector for Jupyter. So before we move on, let me show you that we can also do this for Ethereum based networks as well. So let's actually let me just start that again. So let me just show you how that works on Base in addition to Jupyter. So here it's really the same thing. We can go to I have a Base collection. This just switches the connector to Uniswap. This uses my test ETH address. The network is Base, or you can use mainnet. So basically the same endpoints exist for Solana as for Ethereum. So you can get the status of the chain. So this is the status of the ETH mainnet chain. And I can get my balances on ETH. Let's say ETH, USDC, and WETH. Let's see. Okay, and actually, yeah, I think I've been doing most of my testing on Base. So yeah, here's my Base amounts on this wallet, and then I can also fetch things like how much it costs to do a trade on Uniswap. So yeah, this is Uniswap. So let me estimate the price for a trade, and so this gas price is an ETH for a trade on Uniswap of this much gas limit, which is the typical amount for Uniswap swap on Uniswap in Base terms. But notice what happens when I change the environment to ETH mainnet. So now the gas price is higher. This is the current gas price in ETH terms, and now the gas price is in ETH. So this is basically the price to do a trade on Uniswap on ETH mainnet, which right now is probably something like $6. So that's why I think like I think it is possible to use Hummingbot on ETH mainnet. But it's just I think this estimate gas function will help you estimate exactly how much fees you're paying on different chains. So let's go back to base because we don't want to be paying $6 a trade just to do testing. So now we can basically check the balance as well. So we have balances, we have pull. These are the same functions available across all chains, and so there are some additional functions that the Ethereum connector exposes, like approve, allowances, and so forth. And so that's why I think you can also use these to kind of fetch the actual the allowance as well. When you use price, currently the only connector we have is Uniswap, but after the new structure is available, other connectors should be very easy to add in. But currently we can get the price for, let's say let's do a WETH USDC, and then do something like 0.01 USDC. So this will fetch the price for that trade using the center. So we need 33 USDC is the price, and we can do the same thing for a buy trade like this. Similarly, we can also do the same thing here as well. Do I actually have this much USDC? Let me check my balances here. Actually, I haven't been monitoring the chat here. Actually, I don't know if anyone's actually even listening or chatting. So let me see. Okay. Okay. So I hope people are chatting. Here's the chat. I have no idea. Okay. Sorry, I thought there was a chat interface that I lost here somewhere. YouTube control panel view. Where's my chat icon? Anyway. Okay. Close. Wait. Lost it. Okay. 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 All right. Oh, wait, here it is. Here's my. Oh, sorry. I just saw the question from this person that was probably there for a long time. So, blah blah. Got it. Okay. Yeah. I think the person asked is the question is he ran this arbitrage between KuCoin, and Jupiter. It works, but the status and history report have different statistics than the real ones. The buy and sell orders. He says the reported P&L is wrong because he had it with less USDC and the less WIF. Okay. The data from there are some fee calculation issues that are fixed in the current branch that I'm using right now, which is core. So it's possible that if you're using a different branch, the fee levels recorded, especially on the blockchain trades, don't match what's actually happening. But essentially, you should be able to look at the trade fills database, which is a list of all the trades that are executed on both the Jupiter side and on the exchange side, and you should see the details recorded on that trade in terms of the fee amounts and the trade amounts. That database is what's used by the history command to perform that calculation. So it is possible that we need to revisit the calculations for, let's say, DEXs and make sure that the fee calculations are correct and that the fees are matching what was actually correct on the blockchain. I've spent a bunch of time recently just making sure that the fees recorded match what is actually in the transaction receipt. So that I think I'm confident works well for Solana now. I think the next step is to make sure that the arbitrage strategy is actually is calculating the profitability correctly given what's in the database. But I think it's a long way to answer your question is I'm confident that in the latest branch of Hummingbot in Gateway, the fees are recorded correctly in the database. But I would say I'm not as confident that the profitability calculations are correct, especially in terms of discrepancies between the history command and I think what the V2 arbitrage executor status does. But I think those differences should be resolved pretty soon. But, so yeah, basically a long way of answering, which is check the database, and I think that should be the source of truth in terms of what your fees being paid are. Okay, so now that so now that I'm caught up in terms of questions, let me just go ahead and finish just showing how you can just do a trade on base the same way that you can do for Uniswap. So on base, the way it works is and all for all Ethereum chains, for Ethereum, basically you don't want to have a transaction fail, because if the transaction fails, then you're gonna have to cancel it before allowing you to use this wallet again. So you want to make sure that your Ethereum settings are such a way where your gas fees will succeed almost every time. So that's why I think the way we do it currently, I need to actually investigate a bit more, but I think we actually try to have pretty robust settings on the Ethereum side to try to make sure that your transaction getting through. But there can be issues, because if you have a stuck transaction, that's kind of why we have capabilities to manage nonces on the Ethereum connector, because what we found is you need the capability to cancel a transaction if you end up in a situation where you have a stuck transaction. But hopefully the default settings should allow you to just get a transaction through most of the time. So for instance, let's say I want to buy, let's see how much WETH do I have here? So let's say I'll have 0.006 WETH. Let me price a trade to sell, to buy a small additional amount of WETH. That's about $3 worth of WETH, and I'll go ahead and buy that because it's a test. So this will do a trade on Uniswap base using that. So here's basically the trade. So the trade has been executed. Here's a hash. Here's a hash. And so you can see that this also returns a nonce, and this helps manage if we need to cancel. We can do that afterwards. So we can pull for the transaction hash here in Ethereum, and this returns the same format as in Solana, basically the transaction status as well as the transaction data itself. And just like for Solana, we can do the same thing and sell one token here. Let's 0.01 sell. Let's sell that WETH and sell it again. So that now that it's been executed, here's the hash again, and then we can go and pull for the hash again here. Okay, so here's a key. So we can also see how much fees we paid for this. So these basically by default, Hummingbot is going to send these max priority fee settings. I think once I finish the Solana refactor, I'll probably look at base and Ethereum and try to make sure that these fee settings are available to users, so you can more finely control how you're sending your Ethereum transactions as well as Solana. But we can also go to base scan and look at the transactions on base and see how much we paid for them. Let's take a look. So here's the one that we just did. It looks like we paid about 3 cents for that base transaction. All right, so let's go ahead and just like we did for this one, this bot's still running. Looks like it's actually this is an M3 bot. Oh yeah, okay, I got it. Yeah, this one's still running because even though it was able to do some more arbitrages on the other side, but unfortunately, yeah, there was some more buys and sells because some of these buy trades were not matched with sell trades due to insufficient balance. However, you can see that the sell trades actually did match because each of these sell trades here was matched by the buy trade. Here. So I'm gonna stop this bot because yeah, it looks like the arbitrage strategy the strategy is working, but there's probably more balance handling that we need to do. And I'm going to run the other configuration I have here, which was for base. So the base one it's the same setup as the one for Solana. I define the sex in connector 1 and the dex in connector 2. Here the trading pairs are ETH USDT and WETH USDC. I'm also using $3 because I'm just doing this for test purposes, and I set it so the arbitrage is gonna happen, even if it's unprofitable as well. Here I'm doing a larger delay. Actually, I'll change this to I'll make this 30-second delay because I don't want to. Base is a bit more expensive than Solana, but I do want to make sure it does a few arbitrages in order to kind of really test out how it works. Okay, so let's go ahead and run that. And so to do that, I just need to change this 1 to 2 because I've already added this file here in terms of in new loader script. So again, yeah, I'm not in Binance country, but that shouldn't matter. So it should already be connecting the strategy. Let's pull up the status and see what it's doing. Okay, got it. Yeah. This I believe is an issue that I need to fix actually, because I think this is the issue because right now. It thinks this is too high. This is too high. This is like it's pulling the Ethereum. For some reason, it's pulling the Ethereum gas price instead of the base gas price. So let me actually make sure that I don't know why that's happening. I need to fix that. Okay. Base. See, this gas price is 15 Gwei here. This is the reason why it's doing that. It's too expensive here. Yeah, see, this is the right gas price here. All right, so let's try that again with Hummingbot because I think that was an aberration due to some kind of weird gas price issue. Yeah, okay, so now it's working properly because now it's fetching the gas price correctly, but something's failed over here. It's error submitting buy order. No, invalid. Oh yes, it's the dreaded nonce issue. Unfortunately, these are issues that Gateway actually does do a decent job of managing now because it updated the nonce because the previous one was updated, so now it should be getting filled. So now this base connector is working properly. Okay, it didn't do any unmatched trades. The one error actually was a correctly handled error because I think there's some kind of nonce issue that it handled correctly, and now it's actually doing arbitrage between OKX and Uniswap base. So as you can see, that there's definitely now it's doing 2 trades. Okay, should be doing 1. Okay, what is it doing now? It looks like yes. Okay, now it's it has a nonce issue now, unfortunately. So yeah, this is actually the trade's working. Okay, And so yeah, we need to do. We probably need to do more testing on these nonce issues. So it's also right now this gas price is not fetching the right gas price anymore because now it's too high, I think. Yeah. Okay. So definitely more testing needed, probably for the Ethereum side. So basically, I think the point I'm trying to make is that I think that the Gateway project has a lot of potential because it serves a needed function in terms of like mapping all the complexities that are present in blockchain trading and trying to standardize them so that they're controllable from the client. However, I think a lot more work is needed to create something that's simple, that fits the existing kind of blockchain system, and kind of and basically does enough, but it doesn't do too much, I guess, is what I'm trying to say. And I think it also handles the edge cases that are most common, like the ones that we saw today. And so I've started to kind of really focus on this Gateway project from an engineering standpoint over the past couple of weeks. I've already made a good amount of progress in the refactor. I'm pretty confident that I'll get more done in this current next release and even more in the ones after that. Because I think now we're finally starting to use this software from both our own personal standpoint as well as maintaining it using like kind of different lots of testing bots and so forth. So I think over time we should be able to really kind of improve the user experience here. Okay, so naturally we have this bot running, so it's running for a while. So yeah, there are some issues. So even though there's some issues, it did actually have we did four buys and sells on both Uniswap and on Base, and it looks like it matched the amounts every time. I think, but it basically matched the amounts. We didn't make any money, but we were successfully doing these arbitrage trades. So if there were an arbitrage opportunity between these two tokens, I think the bot would have done the right thing. All right, so finally, I should mention, in terms of next steps, I did actually create a Notion document. Sorry, not this one. Let me pull that up a little bit here. There's a Notion document on a project outline, which kind of describes the status of this revamp project. So I've currently by the end of January, we should have kind of like the main refactor complete in terms of having the architecture where you can basically query the existing routes for Uniswap and for Jupiter, and you should be able to essentially use it with the goal is to also add Meteora and Uniswap as well, and I think by then it probably won't have all the dexes, but it should have support for kind of like these different chains as Ethereum networks. But in the end, once this code is in place, it should be very easy to add back the connectors for other dexes that are in the current main branch of Gateway. The one aspect that we're probably not going to support out of the box are support for other chains. Like I think the current Gateway codebase supports like Tezos and Algorand and a bunch of other kind of like non-EVM chains. I would say I think that we'll have a standard for how to kind of support chains from Ethereum and Solana, and so people can add their chains or have their forks. But I think at least one lesson we've kind of learned is I think we really need to do a good job of supporting the basic chains and the basic dexes first, and adding more endpoints and figuring out how to support that from a structural perspective before adding more and more types of different chains and connectors. So that's why I want to kind of really make sure we have a good architecture in place for Ethereum and for Solana, and just doing the basic functionality before adding more complexity into Gateway. Okay, so I think I'm ending here with the live stream. I hope this was helpful in some ways. But basically, I think we have a lot planned for Gateway. I'll post this Notion doc in the live stream description as well, because it might be helpful for people to see kind of where we're trying to go. But overall, I think this Gateway repo once we're done with the refactor, it should basically operate the exact same way as it is now, but allow people to add more connectors and more strategies just more easily. Okay. All right. So, well, it's been almost 2 hours. I'm going to stop here. No more on the chat, which means that probably no one's watching. It's okay. This is for the recorded audience anyway. So I'll see you next week. We'll be presenting more stuff next week. Haven't figured out exactly what yet, but probably, hopefully, yeah, maybe some DEX LP strategies if we can add Meteora in the next week or so. All right, guys. See you later.